Hello everyone. So today the problem which we will be solving is the third problem of this contest. In case you need any more help from any other contest or problems, please feel free to ask in the comments. I will be there to help you. So let's read the problem statement. The problem says minimum increase to maximize special indices. So the problem is you are given an integer nums of length n and index I is special if nums of I, if first thing to notice is I should be greater than 0 and should be less than n minus 1, means you are not allowed to take the last element, right? Means I should be greater than 0 and I should be less than n minus 1. So if you had, let's say, these many elements, let's say a b c d e, then only the contenders which are there for special elements are a b c and d. Irrespective of what are the values, these are the only contenders. These can't be the special indices, right? All right, let's move to the problem statement again. So these are the special indices. You may perform operations where you choose an index I and increase nums of I by 1. Okay. Your goal is to maximize the number of special indices and minimize the number of operations required to achieve that maximum. All right. Return an integer denoting the minimum number of total operations required. All right. So first, let's try to take up the test case 1, 2, 2 and try to understand that how are things going, right? So let's say I had 1, 2, and 2, right? So what are the possibilities of elements that could be special index? This is the only possibility, right? And this should be greater than this and should be greater than this as well, right? This element should be greater than this element and should be greater than this element as well, right? To make it great two, uh, how would we make this two greater than this one? It's already right. All right, how would we make this two greater than this two? By adding a 1 and the array becomes 1 3 2, and now you can see that this element has been a better one and the answer is 1, right? All right, okay, let's move to the next test case. Next test case is 2133 and 5214. Let's take 2133 only, right? And try to understand it, right? So if I had 2133, right? That was the case. 2133, 21133. Okay, so 2113. Very sorry for this. All right, so to make the elements, what are the possibility? This could be a special index or this could be a special index, right? How many special index could be there? You need to maximize the special index as well, right? So this problem was a bit tricky one, right? Because you need to maximize the number of special index, means you need to make sure that all elements that can be special, you need to make them special irrespective of how many cost you need to get, right? Let's say 2113, right? uh, if I had 2113, right? How many special index could I make? This could be a special index. If I say start, let's say start from this element, this could be a special index and then none can be a special index, right? This can be case 1. Case 2 can be 2113 and I start from this element, right? Still now also only one will be a special index, right? So I think you might understand that the special index in this case can only be one. Now it depends on you that which index are you going to take. If you had 2113, right, you can do one thing, that is try to make this as special. So how much cost will it take? It will take 2 rupees from this side plus 2 and 1 from this side. Ultimately cost becomes 3. All right, if I had 2113 and I want to make this element, so from this side plus 3 and from this side plus 1, ultimately plus 4. So 3 would be the minimal cost that would be needed, right? So we will try to make this element 3 and that will be our answer, right? So I hope the problem statement and all right, so now let's look at a test case first. Uh, let us think if my n was odd, right? Means n modulo 2 is equal to 1. All right. So what happens in that case? Let's try to understand that. So let's say our element was A, B, C, D, E, F, G, right? Now the first things first, the first condition which was given to you was maximize the special numbers, indices, right? Maximize the special indices, right? This was your first priority, right? Now this can be your special index. You can start with this, at least you can start with this, then this and this. Okay, so means three possibilities are there, right? All right, what if we started with C, right? Let's look at that as well. So we know that we can't start with A, neither can't we end on G, right? But we can start with C. So if we start with C, then we can make E as special index and no more special index is there. So in that case, 2 will be there. I hope you are clear with this thought that if you make C as a special index, then B and D can never be special index, right? So the first observation that comes here is if let's say alpha is our special index, right? Then alpha minus 1 and alpha plus 1 can't be special, right? So I hope this thing is pretty clear and obvious to you, right? All right. So we are talking about n modulo 2, right? So we saw that only the first case, if we had where possible we were able to make three index as we were able to make three index special, right? Or a two index special, right? Only two possibilities are there, right? I hope you are not think you can understand that if we 3 3 6 7, yeah, if we are starting with B, three are possible. If we are starting with C, two are possible. And if we are starting with D, two D and F will only be possible. So the value gets decreasing every time. So I hope that is clear to you that you should be starting with B only, right? Starting with B, right? All right. So for any odd number, for any odd number n, right? You need to start with the first element, right? The first index, and by that only you can maximize your special index, right? You can maximize your special index. All right. So I hope till this point your thought is clear for uh, odd number of cases, right? So let's look at a test case that will be a bit clear to us and understand how things will work in odd numbers, right? All right. So let me take a example. The example is 17, 3, 10, 4, and 19, right? So this could be a special index and this could be a special index, right? So two possibilities are there. Let's say you started with 10, so only 10 can be a special index, and that would be the better case, right? So what is the answer? So to make 3 a special index, what we need to add? We need to add at least 15 to it to make it 18, right? So plus 15 gets here, and to make it, and if you add plus 15 to it, it becomes 18 already, and now it is greater than both of the adjacent elements, right? So it became a special index, right? So you added 15 to it. All right, now let's look at 4, right? To make 4 a special index, see whichever element is greater and you need to add that element plus 1, right? So here 19 is the element which is greater. Either 19 is greater or 10, which is greater? 19 is greater. So you need to add at least 16 to it to make it 20, right? And if you make it 20, now it is greater than both the adjacent elements. And now um, you're adding plus 16 to it, and ultimately 31 will be your answer, right? So I hope this part is clear how we will be solving this, right? What is the value that we will be getting it, right? Now let's say your element was already greater than both the adjacent elements, right? This might also be a case. Let me quickly make you go through that, right? Let's say you had 2, you had 5, and let's say you had 3, right? So in that case, if you do a subtraction from this element, like let's say I was saying, let's call it difference 1. Difference 1 was 2 minus 5, right? How much should we add? We should add minus 3. No, not required. You don't need to. If your element is minus, then you don't need to add any element, right? Difference 2 will be 3 minus 5, right? Which is minus 2. Again, we don't need to add any element, right? But let's say the array was 2, or rather 3. Wait a second. Let's say the array was the arrays 5, 2 and 3. So how much should you add? So difference 1 will be 5 minus 2 plus 1, right? In this case also you can do a plus 1, which becomes minus 2, and in this plus 1 minus 1, right? Still it is negative. It means you don't need to add anything yet, right? Now let's look at this. 3 minus 5 minus 2, which is 3 plus 1, you need to add a 4, or difference 2 will be 3 minus 2 plus 1, which is 2, which is you need to add 2 to make it greater. Now which element you need to add to make it at least greater than both elements? That is, which of these are maximum? Why maximum? Because if you add maximum to the element, then you are going to make it above than both of the elements, right? So ultimately maxi will be max of diff comma diff1, and that is what you need to add, which is 4, right? And you will carry on these things on all the elements, and ultimately you will reach your answer, right? So I hope the logic for odd cases are clear to you. All right, so let's try to look at even cases now, and now this becomes interesting part, right? The problem becomes very interesting when the even part comes, and you need to be a bit focused on this as well, right? Now why I'm saying that, because it has reasons, right? Let me bring a great test case for you, so that you can understand that which why I'm saying that, right? uh, if I'm not wrong, the test case is 12, 23. I have written it for you. 13, 17, 21 and 3, right? Now let's try to think of this, right? So even elements have we had, right? So I can, the first possibility is I start with 23, right? I make 23 special, then I make 17 special, 3 and 3, yes. 23 special. Wait a second, let me mark it with another color so that it is more clear to us, right? All right, so let's say red, right? So we can make 23 as special, we can make 17 as special, right? So what happens if you try to do so? Let's look at it, right? So difference 1 is when you try to make 23, right? So difference 1 will be 12 minus 23, right? And difference 2 will be 13 minus 23, right? This gives you plus 1, sorry. So it gives you 10 and plus 1, which gives you 9, minus of both. So this means you don't need to add those elements. It's already a peak, right? You can say already a peak, right? Now let's look at 17, right? So for 17, you need you check at previous element, which is difference 1, which will be 13 minus 17 with plus 1, which is 3, and difference 2 will be 21 minus 17 plus 1, which is 5. So you need to add a 5, and if you add a 5, this 17 becomes 22, and now it became a peak again, right? So your answer will be plus 5. Means you will say, okay, beast, I need to add a plus 5 to make this a maximum or a special index, and ultimately answer will be 5. All right, and if you try to submit that, it will give you a wrong answer, right? So let us look why. Let me quickly erase it, right? Or rather reset the canvas, and let me write the thing once again, right? So the test case was 12, 23, 13, 17, 21 and 3, right? What I said you was, let's start with this. Okay, you started with this element, right? And you said, okay, I need to plus add 0 to this, right? Now you move to 17, and now I'm saying you, why not you don't, mean see, 13 is not able to, 13 won't be a special index, as you have made 23 already a special index. So whenever you are making any element a special index, right, then what happens is you simply are bound to go to plus 2, right? means you can't go to the next element and make it a special index. You need to go to the plus 2th index and try to make it, right, try to make it special, right? But what if I said, right, you went to 17. Now I'm saying that okay, you had the opportunity, let's say I am giving you an opportunity to not make it a special index. Don't try to make it a special index. Go to the next index, 21. Now try to make 21 a special index. If you try to make 21 a special index, what happens is 21 17 minus 21 plus 1, which is 4 3 minus 3, and 3 minus 21 plus 1, which is 19 minus 19. So in that case, you don't need to add any element. So plus 0 from this side, plus 0 from this side, and now the answer is only 0. Amazing, right? So you don't need to add any value to make it a special index. All right. So what does this mean? What does this mean? We try to understand that as well, right? We will try to understand and figure it out that as well. So if you think, what were we doing, right? What was our logic? The logic was we can skip any one element. Logic is skip any one element, any one element if n modulo 2 is 0. Now why I'm saying so, let's say you had a b c d e f, right? 6 elements were there, right? You could make b as a special index or d as a special index, right? So I'm writing at this point b or d could be made special, right? If you thought, okay, let's not make d, let's make e a special index, so b and e will be a special index, right? Now I said, okay, don't make b as a special index, make c a special index. So c, if you make c a special index, now b and d can't be a special index, but e can be a special index. So are you getting the point? That if your n modulo 2 is even, right, then you have an opportunity to skip an element, right? Opportunity to skip the element, right? Only one time, right? You can't, like, you can't say that okay, I will skip more than one element, right? Wait a second. Now why I'm trying to say so, because you need to maximize the number of elements or maximize the number of peaks as well, right? So in order to maximize the peak, you need to make sure that you don't erase more elements. Like let's say you had let me take a bigger case, a b c d e f g h I j. So 5 6 7 8 9 10. So what are the cases? B d f h can be special, right? B d f h can be special, right? Now c e g I can be special, c e and I, so on and so forth. You can see, if you try to skip one element, like you skipped b, right? A can never be a special index, right? And j can never be a special index, so you are not thinking of that. Now you skipped this b, and now you have another test case or another case which can be a possible answer. Like similarly, you could have b as a special index and you are skipping this d. Instead you took e, and then a g, and then an I, right? This is also a possibility, right? So there can be possibilities, right? And whenever we are having possibilities of multiple possibilities, what do we think of? We think of dynamic programming, right? DP. Now let's understand how this DP thing will work. So DP will work only on the cases which are even, right? Right? All right. Now let's try to understand that difference 1 and difference 2 will still be in play, right? Difference 1 and difference 2 will still be there, right? And difference 1 and difference 2 was calculated using nums of I minus nums of I minus 1 minus so really sorry for this, nums of I minus 1 minus nums of I, and nums of I plus 1 minus nums of I, right? This was the case, right? So difference 1 and difference 2 will still be there, but you have one opportunity. Let's say you are on a specific element, right? And you thought, okay, let me skip that, right? Now what happens when you skip that element, right? Let's say you had 12, 23, 13, 17, 21 and 3, right? This was our test case, right? So let's say you thought of, when you came at, you picked 12, right? Now when you picked 12, when you are picking up 12, your index should directly go to 17, right? Your index should be index plus 2. What if you are skipping that element, right? Let's say you are skipping that element, right? You have the right to skip only one element, right? I have shown you why. Because if you try to skip more, I will show you, if you try to skip more than one element, then you can't maximize the number of special characters which you had, right? First things first, let's say I am skipping this 17. So whenever you are skipping this 17, you will move to 21, right? So index will be index plus 1, and you won't add the cost or the burden which this had, right? The difference will be 0. And if you are picking this element, then you will have a 17, or rather a difference, whatever the difference was, right? I think this part is a bit messy for you, right? Let me do a bit of dry run so that you can understand this as well, right? So just hold or carry on with me for like 5 more minutes. You will be damn understanding how things will work, right? So 12, 23, 13, 17, 21 and 3, right? So when you are at 23, right, that's for sure that you need to pick this, right? Let's say you pick this up. Whenever you are picking this up, your difference one is minus from this side and minus from both sides. I'm not explaining that thing again because how it is minus, because 12 minus 23 plus 1 is minus, right? So from this you will get a plus 0, right? And whenever you got a plus 0, you said okay, go to plus 2th index, right? Why plus 2th index? Because 13 can never be a special index if this was a special index, right? Wait, if I am saying this is a special index, then can 13 again be a special index? Definitely not, right? So you will move to this uh, plus 2th index. Now you are at 17, right? Now 17 has two cases. 17 can either pick himself, right? Pick himself. If he pick himself, you can see we need to add a plus 5 to make it 22 and greater than both the adjacent elements, right? And if we, let's just skip this element, then what happens? Plus 0 is added and you go to index plus 1, right? But now you have exhausted your flag, means flag becomes 0, because you have used your opportunity to skip that element. And only once is skipping is possible. I will show you just now. 1 minute I will show you, right? Now you move to 21, right? Now let's try to understand. If you are at 21, you have again opportunity, but can you skip now? No, as you have already used your flag equal to, means your flag or your chance to make it a skippable thing. Now at 21 you don't have that opportunity, right? So 21 you need to take it, and if you take 21 as well, still there will be only 0 added and your answer will be 0 in that case. I hope the thing is clear that we can skip one element. First, I will show you, but skip one element can be skipped. And the second thing is we have opportunity to skip that element, right? Okay, now let me show you why only one skip is possible and why not more than that, right? Okay, let's say my element were 1 A B C D E F G H 538, right? So you picked B and you said okay, I don't want to skip, I don't want D and E both, right? What happens in that case? You have B, you skipped these two, now you have to take F and you are done with that. So only two possibilities, you have maximized only, or you have specialized only two. Is this the best answer? Let's look at that again. Okay, let's say you had a B. Okay, then you can pick D, you can pick F. So anyone with B, D, F will be considered better answer or a greater answer, right? And you need to specialize, the specialized index should be maximized as well. So if you skip that thing, if you skip two elements, you have lost that opportunity, right? And if you lost that opportunity, now you don't have any way that your answer will be correct. But what if we don't skip in succession, right? Means what I'm trying to say is, if I had A B C D E F G H, You picked up this B, right? And you said I will skip this D, I will pick this E. Now again I will skip this F, right? Can you skip this F? This F was already not a contender, right? Then you're probably, you will say, okay, I will skip this G. So again, B and F are only the possible contenders. And this is only two. And we have seen that three is a possibility. So this will fail your test case of the first condition, right? That the maximum, the specialized index should be maximized and you are not able to make it three. So you will fail. So ultimately what you understood from this place is that you can skip only one element, and that can be done only in even cases. Now why not in odd cases? Let's try to understand that as well, right? uh, See, whenever I am making a video on any topic or any problem, I want that you understand the depth of the problem. Even if you like, if you look at the code and like you will say okay, that is okay, but you won't be able to solve or tackle the type of problems again, right? Let's say you had A, B, C, D, E, five elements, right? So what are the possibilities? Either B can be there, D can be there, right? So two possibilities needs to be there, right? Let's say you want to skip this B. Now you can take this C. So A, B, C, D, E. You have to pick this C, right? You are saying I will not pick this D. Then you have to pick this C. And if you pick this C, then this can't be a possibility. This can't be a contender again. And you have no more left. So only one is the possibility. So is this maximized? No. You can take a bigger test case as well. A, B, C, D, E, F, G. Right? B, D, F should be the contenders. If you skip this B, you have C and E only as the contenders left. Right? So for that reason, you are, I hope this is clear that why we are not taking that, in odd cases, why are we not able to skip that element, right? We have to pick every element in skip, in odd rather, right? And in even cases I have shown you how things will work. Now if you have any doubt in this or till this point, you may ask any problems related to me, right, related to that in comments, and I will be happy to help you out. Right now, let's look at, wait, give me a second for this. All right, great, great. So now let's try to look at the code as well, right? So when n is odd, right? What I have said, whenever the n is odd, your answer is 0. You will start with the first index and you will go to n minus 1. And need is maximum of 0, comma max of I minus 1 minus comma nums of I plus 1. Okay, let me make you understand this as well. So while contest, what I had thought was, let's say I had 3 over this place, I had 1 over this place and 5 over this place. Now out of these two, what is the maximum? Maximum is 5. So I will do 5 minus 1 plus 1, right? Why plus 1? Because to make it bigger than 5, I need to add a plus 1. Let's say I add a 2 over here. So 5 minus 2 plus 1. How much is this? 3 plus 1, 4. So you need to add 4 to this and it becomes 6, right? So I will take max of this element or this element, right? So max of nums of I minus 1 or nums of I plus 1, whatever the value is, plus 1 minus nums of I, right? What we did in this case, right? And after that, need is found and answer will be plus equal to need. All right, so answer will be added every time and at the end we just need to return answer, right? Else the even case comes into play. And what are we doing in even case? Let's look at, we are assigning a dp of size n and 2. Why 2? Because every time what happens is you have pick and not pick dp, right? This becomes a pick and not pick dp, right? Interesting problem, right? So you had pick and not pick. Whenever you are, let's say, skipping an element, then your flag, right, flag becomes 0, right? That you have exhausted your opportunity, right? So that is the reason why I have assigned a 2d dp, which is a 2 at the size of dp is 2, right? So first changing parameter is, let's say you had a solve function, right? And solve function has index and a flag, right? So index is changing and the flag is changing, right? So these are the two changing variables. So I hope you know that we will be assigning the dp as dp of index comma flag, right? And you understand index is on which index we are currently on, and flag is the value of that we can skip that element or not, right? So now let's look at how we are going to solve this, right? So if we are at the second last element, right, we can return a 0, right? Now let's try to understand that as well, why we are trying to, why we will return a 0 and all of that, right? So give me a minute. All right, so let's say you had, I'm taking 12 23 example only, 12 23 13 17 21 and a 3, right? So whenever you reached this index, right, after that you don't need to means proceed further because you don't have any element which will be useful for you. So if you reach till n minus 1, return a 0, right? And let's first look, this is the memoization line, right? I hope you know this, that this is a memoization line, right? So you just don't need to like understand this, but yeah, not understand this means you know how to figure this out, that if you had a dp and index flag is not equal to -1, you are simply returning that very element, right? Need is whatever we did in the odd case, right? Need is the same value we are finding need, right? Let's say I had a skip, I had a not skip. If my flag is equal to 1 means I have the opportunity to skip that element. So if I skip that element, then I don't want to, I let's say I am skipping this 17, right? If we are skipping this 17, will you add the need? Will you, let me write it, will you add the need value? No, right? You won't be adding whatever is needed to make it a special number, so skip that. So if we are skipping it, we are simply adding, 0 plus solve of index plus 1 means you need to go to the next index and your flag becomes 0, right? Let's say we are trying to not skip, right? We are not skipping means, let's say we are picking this element. So what if we are picking this element? So if you pick this element, you need to add the need, right? Need will be added in your answer and you will simply go to plus 2. Why plus 2? Because if you are making this element as a special index, then the index which is next to it can't be a special index any day, right? Because if you make this 22, now this is 21 and this is 13, now this is a special index. Now how will you make this again a special index again? I hope this thing is a bit clear to you, right? So if not skip, you need to add that element, solve index plus 2 nums, and the flag, whatever the value of flag was, it remains the same, and you are returning dp of index comma flag is minimum of the skip comma not skip. So ultimately your memorization and the even cases comes to an end. Let's look at the test case. Let's look at the time complexity as well. So let's say we had an even odd case, right? So for odd case, the time complexity is pretty simple, we go of n, right? For odd case, right? And let's look at for even case. For even case, our dp was index comma flag, right? So these are the two changing state or the changing variables that are there. So index will go till big O of n and flag will go till at max 2, right? So which becomes big O of n ultimately. So the time complexity of this code is big O of n only, right? So I hope this part is clear to you and you are returning the solve function whatever value that gives, right? So this was all about the problem. If you have any doubt, please do ask in the comments. And if you need to any more problems from my side, please feel free to ask. Thanks for watching. Please do subscribe if I was able to help you out. Thanks for watching again.